Hello, welcome to the second episode of Async Await. We did an episode around the same time last week, and we basically did go into the basics of Async Await, how to use it, how to do flow control with Async Await. We did start a little bit into kind of like looking how they are not blocking. So if you do a wait that it's actually not blocking the event loop, we started looking into that. And then we wanted to go really into performance last time, and basically the Twitch stream got kind of cut off. Like we ran into some internet issues. So today we will basically go and start from right there. So actually we'll repeat a little bit of the sorry, not the flow control, but the showing that actually things still run in parallel, even though we are kind of awaiting on one space. And then we'll do performance debugging and promise integration. Should be around an hour to an hour and a half to get everything done. So for you who have been kind of not following along, who have been like missing maybe the last episode, they may not know that there's actually a repo where all the examples that I'm working on are actually here. So you can basically follow along if you wanted to. Right now we're looking at util.js, which is kind of the little task we created to simulate asynchronous operations, which you're going to look at next. But basically we will continue around non-blocking, so number 15. So if you want to follow along, that's kind of where we'll continue. Also, if you missed, kind of want to catch up and you missed the first episode, I basically post all the episodes here. I actually created a playlist for async await stuff, so I'm going to put that in the chat here. So basically what that means is that all the episodes that are related to async await will go into this playlist. So if you just, kind of put that into your playlist or whatever, you can then watch the first one if you missed it, and the second one here, what you're doing right now, will also go in there. Okay, so make my terminal big. So basically, let's look at how we actually simulate a promise. So we called it a task. It's a promise, really. But basically what we did is we said, for these kind of test cases, I want to be able to create like a promise and tell you what the result will be, or if that promise will throw kind of reject with an error, right? And then I want you I want to be able to tell like when is it actually going to resolve or reject. So basically how that's implemented under the hood is that we just set a timeout, right? And then when the timeout expires, we basically decide to reject. So basically here, if the error was said, we will kind of wait and then we'll reject. If no error was said, we will resolve. And it's kind of backwards. You're giving us the result before, right? So again, this is just like to simulate this kind of workflow. So just to make it easy to play around with this, right? And then also we have a debug task here. So basically we're using the debug library. And so we can kind of get an insight on how things happen. When did the promise start executing? When did the promise start reject? When did it reject? When did it resolve? And again, make sure to watch. It's all in this episode here. We explain all of this in detail. So if you kind of missed that one, make sure to watch that. Again, link is in the chat. Okay, and so we'll just go into the we kind of repeat a little bit here what we did last time. Let me see. So basically we were doing non-blocking. So basically what we were trying to show is like, some people might be confused that, okay, if I wait here, right, it doesn't go to the next line until this promise get users here resolved, right? So get users is a promise that resolves a bunch of users. Like in this case here, we getting user 1, 2, 3, then 4, 5, 6, and 7, 8, 9. So some people might be, okay, so it's true that this line here, right, won't be called until that line above kind of resolved. If it's rejected, it will basically just bubble out, and we should technically we should handle that error. We aren't right now, but basically what's actually happening is it does kind of pause here, but it doesn't really pause executing Java. Sorry, executing JavaScript in general. So what's actually happening is it's kind of like saying, okay, I was in this function, right? I'm going to remember that that point, that line, let's say line 16, and then I know that once that get users promise resolves, I will continue on line 17, right? But until it resolves, I can now go and do other stuff, because, you know, most likely we'll do some asynchronous things, like we might be waiting for a request to come back, we might be reading a file, whatever. So the thing is now, the idea is that in the meantime, I can actually start executing this function, right? Because actually we are, so what's happening here is there's an event loop going on, right? You have to think about it in the event loop. So we set a timer for 5 milliseconds, right? So the event loop's spinning, and then it's like, oh, 5 milliseconds elapsed. I will now execute get batch uno, right? So it does that. Get batch uno actually finishes. It's pretty much done for all intents and purposes, and it just like basically registered this kind of, you can think of it almost like a callback to continue on line 17. And then what happens is the end loop keeps spinning, right? And so now it's like, oh, it's actually now 10 milliseconds have elapsed. I will now execute, right? Because of this one, I will now go and start get batch DOS. And so it will then execute these two lines, and again the same thing will happen. It's like, okay, I'm done with this function because I actually can't continue until this other get users resolved. And so it kind of remembers to return to there, but it basically keeps the event keeps spinning and can keep executing other JavaScript. That's the whole point what you're trying to show you. So if you execute this, we can actually see that batch uno, batch DOS, got executed really quickly, one after the other, and then actually finally we got batch uno after the fact, right? So you can clearly see that getting batch uno did not stop everything, right? Because if it would, we would have been sitting here until we logged got batch uno, but we didn't. We basically logged get batch uno, get batch DOS, and tres, and so on, right? So now we can use our little debug thing that we showed earlier to get a little more insight. So we can basically say, okay, debug the task, and in the as you saw earlier in the util, we registered that. Debug the task, and when and then log that to the console, and then we're executing. The %sign means we're executing the current file. So let's see what's actually happening under the hood. So it says getting batch uno. It actually executes that promise, right? But now the promise hasn't resolved. So it's like, okay, I can't do anything at this point until the promise is resolved. Let's go ahead and then it goes and executes batch DOS, and then tres, and so on. And then you can see that they start resolving. So for instance, in this case, actually, 7 happened to resolve before 1. No, sorry, it executed, right? And then 1 actually resolved, right? And then 4 resolved. And then kind of 7 resolved. At some point 2, and see, you can see that 2 didn't actually execute until here. So it's like, you can clearly see, so basically there's also no wait in here, so that's how this kind of all happens to be in weird orders. But the main point here is to understand is that the event loop was spinning. A wait does not stop your JavaScript in general from running. It just puts kind of like a marker in your function to continue on later, and then it kind of leaves that function be, and that function will not execute further until that promise has resolved. So I hope that's clear. If you have any questions, I have the chat open here on the left. Let me know, and I can try to help. So that's the whole point for having this as a stream, because then you guys get to ask questions, and I can actually answer them. Otherwise, I could just stream class this, and then I could make it more perfect. Right? Could make less mistakes. All right, so now let's look a little bit of what not to do with promises, and even especially async await as well. So basically, we can get really deep nesting really quickly with async await. So for instance, here we're saying we're awaiting get user 2, right? So get user, and that's actually then maybe get user because it does some more validation. It's a little contrived example, but basically what's happening here, then we await another thing, and inside of that we actually await another thing. So we're getting like really deep nesting. And so the outer get user here, that promise, right? Each time we create a promise. So that's another thing. Each time there's an async function, when we call it, a promise is created, no matter what. And we had this actually in the basics. So again, if you watch the first video, you will see that even if something just returns a value, it still creates a promise anyways. So, so you can get really easily nested. And in this case here, this get user promise cannot resolve until all the nested promises inside of it resolve. So you could get a really big chain of promises that that then kind of take up memory and so on. So you have to be a little bit careful of not, because it's now so easy and it looks kind of so nice, right? It's kind of easy to read. It's still a lot of complexity going on under the hood, so be careful with that. That's basically the point of that. So if we run this now, we can actually run this with the debugger on, and we can kind of see what's going on here under the hood. That all these every time it says executing, we get a promise basically that is created. So just be careful with that a little bit. Let's go to the next one. This one is actually an easier way to kind of simulate what happens if you have too many promises going on. So what we're actually doing here, we have 10,000 IDs, right? We create 10,000 IDs. We fill them here, and then we say, please map all these IDs to promises, right? This is what we're doing here, and then resolve them all in parallel. And we saw earlier that with await and promises, you can basically serially or sequentially resolve kind of like asynchronous operations, or you can do it in parallel. So in this case here, since none of the users depends on another user, we can just do it in parallel, like however fast you can. So let's say, for instance, there would be a server request that goes on, right? We don't want to wait till the first user comes back before we execute the second, and so on. So we already went into more detail with that in the last episode, but basically just keep in mind that what we're doing here, we're creating promises, and all these promises will then be passed to promise.all, and they resolve however they like. And then thanks for following, I can't say that name. Please, like, if you want me to say your name right, please type it in the chat. Jivel, whatever. This is a little tricky. But thanks for following anyways. I appreciate it. So all these execute all in parallel, and then we're all happy, right? And then we basically get an ordered array. So they come back in the order that we gave the promises. So like, here we have the IDs in order, so the resolved users will be correctly ordered. So that's kind of the promise magic that promise.all does. But the point here is that we're creating a ton of them. And so if we can execute this will run. This will take a while because creating 10,000 promises. So while I'm speaking, I'll tell you when it's done. Okay, it's done now. So hi everyone again. Thanks for everyone who just joined. Thanks for joining. I'm going to go back now to the screen. So here we got like all these promises resolved. It took a while, and you can imagine all these promises like took some memory, right? Not good. So we can actually measure that. So what we'll do is we're gonna run this with Budo. So basically, what I created here are two scripts. One of them is Budo, and one of them is inspect. So Budo allows us to just basically run things in the browser directly. So you just give it a file, and Budo will just kind of make it into a web page for you, kind of, and it just runs directly in the browser. So basically, what we can do is we can say npm run Budo. I'm just going to show Budo real quick. That's why I was over here. So Budo, I highly recommend it. It's super easy. We installed it here as a dev dependency, and we're running it this way, so people can just get started with the project without having to install anything global, right? That's the idea. So Budo is super easy to use. So you'll see right now how awesome it is. So basically what we do, we'll pass arguments to Budo, via this kind of minus minus thing. That's the way to pass arguments to npm scripts. So now let's see which number that was. This was number 17. So now that's gonna open. We can now open that in the browser. You can also tell Buddha to open automatically, but I like to control when things open in my browser. So now if you open DevTools, you'll see that we have all these tasks executing. So basically, whatever we log normally to the console, we're going to detach this one actually. Is now basically we can see this here. So okay, so what we'll do actually, we will refresh this, and we'll take some performance metrics here. So what we'll do first is we'll just look at how taking heap snapshot and seeing kind of proving that all the promises are memory. And hey hein Mac, okay. Velispo, okay. Velispo. Yeah, welcome. Actually, I was just in Medellin. You might know. I was actually the last few streams I did from there. Now I'm back in Cheyenne, Wyoming. So welcome to the stream. So what we'll do, we'll refresh, and kind of when we have a bunch of promises aggregated before the resolve, we'll take a snapshot. So let's do that. Boom, and then snapshotting. So at this point, the promises have been created and they haven't been resolved yet. And you can see snapshotting is taking a long time. And that's also because our promises are kind of busy. Oh, okay, that's not good. That's not cool. Why did it disconnect? Oh, it snapped. Not cool. So, oh, we still got our snapshot. Okay, that's interesting. See if we got our promises though. So yeah, that didn't really work out right. We didn't just have one promise. I promise, no pun intended. So still need that one. So delete that snapshot. Let's do this one more time. So we'll wait a little bit. 1, 2, 3, 4. Okay. So let's see, hopefully it doesn't crash again. Otherwise we'll go to 1,000. So the main idea what I want to do here is I want to take a snapshot while all these promises are basically pending. Okay, so this looks good. Now we are, that's not what I wanted to show. So where are the promises? Here. So basically, we can see that we have about a lot of them. We have 20,000 in this case, promises, and they take up about 4 megabytes of space total. That's not good, right? Because also promises have overhead, they're objects, they might be holding on to some things, so you got to be careful with that. So that was the whole point of showing this, but there's actually a better way to kind of show like so say like now you have these promises, and now you want to find out where did those get created, right? And it's actually really tricky. I personally find it tricky here because we see like the resolve, okay, that's part of the promise, that's fine. Then we have a context, still no idea where that is. So it's really hard to figure out with this snapshot why we have these promises. So that's another way to profile. So what we can do is we can say record allocation profile, and what that means is it will actually record the allocations as they happen, and whenever an allocation happens, it will then basically say, okay, where did that happen? What's the stack trace, right? So it will basically allow us to see where did all our promises get created. So what I will do, I will let's see how we can do this. So we'll refresh the page and immediately. So this one we don't need. Let's see. So this is our page. So what we'll do, we'll start this and we'll refresh the page over here. So let's see if that actually works. So it's recording, and then actually we could stop because we had our promises created at this point. And so that's what we can see here. Where did all our things get created? So we see the promise here, right? So those are the promises, those are the culprits. And then we can see that, oh, it's get users, right? So this is really, really, really useful if you have a memory leak due to promises or whatever, and you want to find out which functions are creating them. You can basically repeat whatever kind of, you have to reproduce what is causing the leak, and then you basically can take a allocation profile, and then you can figure it out. So here we have now, we can click on that, which is also cool. And then it takes us right to the function where we were creating all these promises, which is, it doesn't tell us the line. So as far as I know, that might be coming, but at this point it just basically tells us stack trace. So at least if you have small functions, it's going to be really obvious, right? If you have large functions, which we shouldn't have anyways, not going to be that obvious, but with this it's kind of obvious that here we're creating promises. So that's kind of what I wanted to show here. There's another thing you can do. You can also take a record allocation timeline, and we're just going to do that just to have tried them all. I don't find this too useful, but let's do it. So we'll start, then we refresh our page over here, and we can actually see in real time what's going on here, and then we can stop it. And now it's basically creating just a snapshot. So it's just a snapshot, but it tells us like at what time did we create how much memory. So here we can clearly see that right in the beginning, right when we started, we went up in memory real quick. So it's kind of gives us, it's a combination of snapshot and timeline, right? So we can see when did we actually create all these. So now actually here we also have our promises. So other cool thing is, so we can click on this and we can look at, okay, so we have that, but we also can look at the allocation stack. And so there we have this other, it's kind of the similar feature that we had before, right? With the, what was the other one called? The allocation profile, right? So again, it tells us where we did allocate it. So the difference between the snapshot and you can also use this for other things, not just promises, but the main difference here between creating a snapshot and doing this allocation profile or timeline is that the snapshot basically, it just looks at the memory when you create the snapshot, right? It has no overhead before or after. It just has overhead when you're collecting that data. But then it doesn't know why these objects are in memory anymore. So it doesn't know how they got created. And therefore it cannot tell you which function is the culprit. Then you have to actually look at what they close over, kind of trying to find out where it comes from. But with these other two things, basically it's watching as things get allocated memory. So at that point, I can actually say, oh, hold on, I don't want to just collect what gets created. I want to get the stack trace so I can tell you which function that was in. I hope that makes sense. So again, any question, also if anything is, I hope you guys can hear my music. I have some music. I'm using this Creative Commons thing from SoundCloud, so Amoeba Crew, which is actually a pretty good playlist, and all this music I can play on Twitch, and they will not remove the sound later, which they will do if there's any copyrighted music. So I hope you can hear that, because otherwise there's no point in playing it. Okay, so are there any questions so far? No. Okay. So by the way, anyone who just joined, very welcome. We just basically looked at how to profile promises in memory, and the short end is that using allocation profile and allocation timeline basically helps us much more to find out where the promises were created versus a heap snapshot that just shows us what's in memory. So that's kind of the last two things that we did for anyone who just joined. You can also do the same thing with node inspect. And I will just basically show this just so people know this is not only available inside the browser. So obviously here we could run it with bootto because all our code is just, it works in the browser. There's no node stuff going on, right? But hold on, before I do that, actually, sorry, getting ahead of myself. So what we'll do next, actually, we're going to profile a little bit of performance. So we want to see like how do these promises actually execute, and what does maybe this memory overhead actually cause related to our performance. So what we'll do, we just hit this here. You can just say, I want to reload the page and I want to kind of profile it while it's reloading. So let's do that. So now it reloads the page over here. At this point, all these promises are executing and so on, right? And we'll wait like 5, 6, 7 seconds, and then we'll stop it because that's enough. And now let's see what happens. Okay, you can't hear the music. That is not cool. Why can't you hear? Okay, I'm gonna make the music louder. Estrada, and you tell me when you can hear it. Can you hear it now? I just want to make sure it's not louder, too loud compared to me speaking. So let me know if you can hear the music, or if you can't. If you can't, then I'm sorry. I don't want to. I had instances where the music was like way too loud. Okay. So let me know if you still can't hear it. I hope you can hear it now. Okay, now what is this? Wow, what in the world, right? Well, this is all. This is a CPU program. So we're gonna zoom in a little bit, because this is basically the same thing over and over. And the thing is, what we're gonna see is minor GC a lot, right? So what does it mean? So it spent. So it did a minor GC here. I think it did some others somewhere else. So here we have another one, right? So, and you can see that that takes a lot of time. So basically, this is a timeline, right? So the code was executing. Here we were around 3.5 seconds, and so on. So the wider this is, right, the more time was spent. So that means like we actually spent, like, compared to all these other things here, like we did like all these other things that don't take much time at all, right? Like all these other things here, they almost take no time. And then the GC kicks in and it freaking like steals all our performance. Like look at how long this is. It doesn't end. Wow, look at that. Woohoo! And it's a minor GC. So comparatively to all the other stuff, it actually, and then the thing is, it's the stop the world garbage collector. As you can see, while this thing is happening, everything else stops and then it continues over here again. So this is bad. So as you can see, creating a crazy amount of promises, or any other object for that matter, but you know, I kind of see the danger with promises a little bit, because people might be overusing async await or whatever. Just be warned that, look, there's another one. You will create a bunch of work for the garbage collector, and that will hurt your performance. So that's the other one thing I wanted to show. Any questions? And I hope people can hear the music now. Hopefully. Okay, let's go with that. Let's. I'm gonna assume that everyone can hear the music, unless someone tells me that they can't. So let's pop this back in, and we'll show how to do this with Node now. Can delete this one. So what we can do, we can run our application with Node inspect. So watch, by the way, here. So I'm going to start the Node. So watch over here. I'm going to start this process now with Node inspect break, and I'm going to do inspect break because what that does, it says launch the application, stop immediately, because we want to have some time to attach the debugger, right? Otherwise, it will just execute the prompt that we already run. If the script was short, it would just finish before we could even do anything. Obviously, if you're running a server, you might not have to do that, because the server will just sit there and wait. So you can attach whenever you want. So then you just would do inspect, but we're going to do inspect break. So let's do that. And now, did you see that? Let me do it again. So, oh, now it should disappear again. So now it went kind of grayish. If you turn it back on, it will go green. You'll see it. Okay, so basically, Chrome kind of monitors our computer magically, and it notices that there is a debugger listening, because it realizes that there's something listening on the support over here. So, what this means, we can now open Chrome dedicated, Node dedicated Chrome DevTools, which is kind of cool. Actually, move that over here in the middle. So basically what happened here is we stopped at the first line, and if anyone is unfamiliar with that line, that's what Node does to wrap your code, right? To basically get the exports out. So that's where the file name and dir name comes from, by the way. It's not a global. It magically gets injected into you. So that's what that weird line is on top. So what we will do is we'll basically just show that you can also profile the memory allocation. Okay, so we will start it, and basically once we start it, it will now already start executing stuff. And then whenever we feel like it, we'll just stop, and we have the same kind of result. So this is not with Node, right? So, and now since we stopped it, it was able to finish over here. You saw that, right? But basically, like, wow, this is pretty amazing. If anyone has done Node for the last 3 years, they should know that this is pretty unheard of, that we can debug that awesomely. Now, if we go here, why is this in the VM? It's probably because our process finished, right? So, but it somehow still remembered that code. So we can click on here, we can see exactly where, you know, kind of has still the file name and the function. Exactly like in the browser. So we can basically do the same thing that we can do with, in the browser we can now do with Node. Obviously this only works locally, unfortunately, which is, by the way, why, you know, anyone who doesn't know, I work for Node Source, and we basically try to give this kind of functionality to enterprises in production, right? So you can kind of do these kind of things, or at least like similar to this, while your process is running in production, because most of you will know that sometimes it's very hard if you have a problem to reproduce locally. But if you can reproduce locally, then now like this Node Inspect integration with Chrome DevTools and so on gives us a lot of superpowers. So pretty cool. Now, we're going to do, just for to complete this, we're just going to show that also the profiler works. So we can do the same thing. We can just basically, so debug is a torch. Once we start it, it will actually start running. So now all these promises get created. Some of them start executing. We'll wait like a few more seconds. Boom, boom, boom. Wait. Okay, done. And now, so here it was not doing anything. That is interesting. So the program basically just means that there was no Java. I'm trying to get this part here running. I can't. Let's do this. Okay. So the program part is basically just like it's idling. It's not doing anything. But you can still see that we got a lot of garbage collection here. So we have the same kind of, while we were running in JavaScript, we caused a lot of garbage collection. Here we can see boom, 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 all these things. And they're like pretty high percentage of our code. Not cool at all. So you want to avoid that. Don't create too many promises. But you know, I really like async await. I mean, that's why I did this series, because I feel like it's a cool way to write asynchronous code. If you watch episode 1, which I will post again in the snapshot, because whoever just joined won't see the chat. That's unfortunately how it works in Twitch. So this is a playlist where the first episode is, and the second episode will also be here. So basically, you will see in that episode that I really like the idea that it's so much more similar to synchronous code. We only have one way of thinking now, one way of try-catching. For loops work, you know, conditionals like if-else work. So it's really awesome. I really like it. But you still got to be careful with how you do them, right? And otherwise, you if you just keep in mind, it's very, very simple. So I'm gonna try to do this like this. So very simple and very, very cool, but don't overuse it. It's a lot of complexity that's going on under the hood that you don't see. And that's kind of the cool and the bad, right? Because you don't see it, so you don't have to deal with it in your code. But you still should be careful, because just because you don't see it doesn't mean it's not happening. So kind of understand that async await creates promises, and the promises have an overhead. Just understand that and keep that in mind. And once in a while, profile your app and see what's going on. Maybe profile and see how many promises you have at a certain point of time. So just be careful with it. And that's the rant. Now we're going to go on to some more fun stuff. So let's close this one. And now we're going to get to some really fun stuff. So basically, as I mentioned, async await uses promises under the hood. And that means that we can actually integrate really with a lot of promise libraries that already exist. So there's a plethora of promise libraries that exist already in the ecosystem. You can install them from npm. Some of them don't really work that well because they require some, they rely on chaining, or they're not somehow not compatible with async await. But we'll go through some that are compatible, and we'll show how you can do some awesome stuff with these libraries combined with async await. So here, Cinder Source, very prolific, especially also with promises. He has a whole list of packages here. Now, a lot of them are fairly simple. Like a lot of them are actually kind of like one-liners, two-liners, three-liners. Some of them are also longer. But all of them kind of do some really useful thing. Like, I mean, you might use it at some point. This one, pify, is a promisify thing that's kind of, you probably know that Node.js util module now has a promisify function on it that allows you to promisify kind of like fs.read file or whatever. Pify does the same thing. It also works in the browser, so that's the reason to use it. It does some magic where, let me actually open it up. It does some magic where if you give it an object, it will try to, here for instance, right? It will try to promisify all the functions on it. I'm not such a huge fan of that because there's so much stuff happening without you knowing. Like, everything gets promisified, and do you even want to be everything promisified? So it's convenient, but I would still rely on just using one function at a time. So this is if you want to use it in the browser. You can also use it in Node, but again, Node already has a util or promisify you can use. So so now the next one that I found interesting was delay. So that actually allows you to delay the execution of a promise, for basically using a promise to resolve after a certain time, so you can delay. Well, the cool thing is that with async await, we can actually really like kind of delay. It's almost like a sleep in a bash script, right? Because what it will do, it will wait here, and then it will continue here. Now, again, it doesn't really delay your code, right? Like other codes could still run in the background, so Node will not stop. It will just basically say, okay, I will not execute further in this function, right? I will do all kind of other stuff. And then after the delay time has elapsed, I will continue in this function whenever I have some time. So basically, imagine again, event loop, right? Whenever everything else is done, basically like there's no JavaScript running at that time and the event loop can spin, then it will say, oh, the delay has expired. Let me actually continue in this function over here. That's kind of how that works. Again, it's not, so it used to be, or it's still true, for any synchronous function, right? Any synchronous function that's like this. The event loop will be blocked while you are in this function. That's true, right? So basically, until I exit the function body, and and I go back from JavaScript to kind of give the control back to Node, that the event loop is blocked because it actually does execute your code. So if I was doing really bad things in here, like reading file synchronously or whatever, I would block the entire event loop. That is not true with async await. So basically, when I have an async function, I put in await here, it now allows the event loop to continue, even though I haven't reached the end of the function body. And I already iterated that in the beginning of this episode and the last one. It's really important to understand. So what's happening here, it basically just says, okay, I will continue in this function when the delay is done, but in the meantime, other things can happen. So you're not blocking your server or anything like that. So let's see how that works. Let's run it. All right, cool. So we have a delay of, and we can see that delay is not exact, right? So we set a delay of 100. So why is the delay not exact? Well, it's because the event loop basically checks if there's a timer going on under the hood. Obviously, we're going to look at the code in a second. Basically, the event loop keeps going in circles and it checks if the timers have expired, right? But it might actually get there a little later. So the timer expired like 6 milliseconds before that, before it actually was able to then, call our code. So now, obviously, if we make that 1,000, it will wait 1,000. So that's kind of cool. So you could just, delay in the middle of a function. I think it's kind of nice. Let's look at the code a little bit. So delay is basically just creating a promise, right? And then here's the promise, and then basically it sets a timeout, right? And then when the timer is done, expired, it will then resolve it. So now here's a weird thing, will resolve, what does it come from? So there's some extra stuff in here where it allows you to reject it. You can create a promise that rejects. I guess that's really useful for testing. And you can cancel it. Okay, so that's interesting. So basically what we could do, we could delay execution and then cancel it. No, wouldn't do anything. Okay, but the main idea here is that we set a timeout. It basically works very similar to our little task that we created in our util, right? I mean, that's pretty much the same thing, except that we're not just delaying, we're actually returning something, or we are rejecting, right? But I thought it's kind of cool. Now let's look at the all thing. So we already looked at promise.all last time, but there's another p-all up here. So that's basically doing a little more magic for us. So basically what that does, and you can see like how it's implemented, right? So it all relies on just pmap. Don't ask me exactly, we could like look at pmap, but we're not trying to fully understand how all of this works. I'm just trying to show you basically how we can use all these cool libraries that already exist, and kind of use them with async await. Now what's the question? Is there another way to create a for loop that handles the promises in order? So yes, so if you look at, I'm actually going to show this over here because and let me put basic code, since if you joined late you might not have that link. So this is where I have all the examples, and you can see the section. I have sequential, so you can do a for off, which is pretty much what you pasted there. However, you can also do a for I. Alright, and if that doesn't answer your question, if I misunderstood, let me know. But you can do a for I loop, and you can also do a while loop. And in each of the cases, obviously they are ordered because we're pushing them in order. Now, again, for parallel execution, you want to use promise.all, right? So, but that's a little different. I hope that answers your question, Strata. I think your name's, I can't remember your first name, but I think I saw that on Twitter. But I'm going to call you Strata until. But you can chat me your first name, so I'll try to remember for next time. So I hope that answers your question. If not, let me know. And I know there's some sort of delay, so bear with me if you already typed your question and I keep asking for the question. That's because there's a delay with Twitch. Okay, awesome. Thank you. You're welcome. So now the all thing that actually does do something cool. So again, what we're looking at pure map, and now that's more complex, right? Not going to try to understand this, but here's the thing, right? If you really, Alejandro, okay, thank you. So here's the cool thing: if you're trying to understand how all this stuff works under the hood, like I said before, it's good to understand a little bit. You can like read this code. So it's pretty cool. I'm not a huge fan of this huge indentation, but I mean that shouldn't be a hindrance to kind of look through the code, try to see what it does, try to understand it, maybe run it, run the test, maybe just clone it, run the test, change some stuff, and see what happens. That'd be a cool way to learn. You'll be way ahead of everyone else understanding promises and so on. And since async await, as I said, I believe will be the way we're doing asynchronous code in the browser and in Node in the future, and they are based on promises, probably a good idea to understand promises at this point. So, p.all, what does it do? It's kind of like promise.all, but it basically allows us to put a concurrency, which is really cool. So let's say, you have 1,000 links, right? So you have 1,000 links, right? And you're trying to resolve all of them. But at the same time, maybe the links are actually all from GitHub or something, right? Maybe you're trying to resolve, and there's some API rating limit, and you want to not go over it or whatever, or you don't want to overuse some network, whatever. And you want to kind of say, I want to do only 10 at a time, right? So I'm going to kick off 10, and only once the first one resolves, then can I add another one. So there'll never be more than 10 in flight. And why is it also important? And chat at me quickly. You know the answer. Why is it important to not have so many promises in flight? If you just watched the last 15 minutes, you should know. Music's too loud. Okay, thanks for letting me know. Before we couldn't hear it at all, so now it should be better. Thanks for letting me know, and yeah, definitely let me know that as soon as you get annoyed by it. Garbage collection, exactly. Happy bit and byte. Exactly. So basically, as we saw earlier, if you create a bunch of promises, you drive your garbage collector crazy. Now, why does it make a difference if you create them like one after the other? Well, because the longer the promises are around, the more work you create for the garbage collector. So if you have short-lived objects, that is actually better than having a bunch of long-lived objects. So let's say you have 10 promises and you know they'll resolve in, like, let's say within 200 milliseconds, all of them. At that point, collecting them and cleaning that up may be much faster than if you have like 100 promises and then maybe 50 of those stick around for a long time. And that means at that point they get copied and all this stuff. Now, I don't want to go into too much detail. If people are really interested, I might do an episode on memory and garbage collection. But actually, there is I'm going to paste a talk of mine in here that is just about that. And I know you can't see anything. You can just see me, but that's fine. I will post it in the... I did a memory profiling for mere mortals talk. So, and I give that... So this is probably this one is actually, right, since we have Colombians here, this one is, I gave in Medellin. So Alejandro, I think you may be also from Colombia. So this is the one that I gave in Medellin. And that gives you a much better idea about, you know, why the garbage collector gets way more busy if objects are sticking around longer. So that was the right answer, bit and byte. And I'm going to get to your question in a second. So go back to this. So this is the talk that I just posted. This one here. So now we're going to go back to repeat it all. So basically here this is a concurrency, and so it will automatically, the cool thing is, we'll see in a second, it will not even create the promises yet. It's not only that it will kind of not allow them to resolve with some weird thing, it will just hold off on creating them. So what's going on here? How can it hold off on creating them? Well, if we were passing it a promise, right? So piece by piece here, right? So all, right? And we tell it concurrency. So we can say all 10. That's how it works, right? So now we have a bunch of IDs. Obviously, 10 is all of them. So let's just do concurrency 2. And then what we'll do, we create tasks. So what's happening here? As you saw probably earlier in the promise overflow one, we basically map the IDs to just a task. So we map them actually to promises. But we don't want to do that yet because, as we saw, promises are eager. Like first episode, we went more in detail of that. So promises are eager. So once you kind of create one, thank you for following me, Puka. If you have a better name, Puka, let me know what your name is. Just put it in the chat. I want to get to know you know, all of you who are kind of watching on a regular basis, so I can say your names right. It's from Argentina. Okay. Well, thank you. I think now I'm confused. Alejandro, right? Yeah. Okay. Thank you, Alejandro, for correcting that. That was in Argentina. It was in South America though, so I got that one right. So, anyways, so as we mentioned, episode 1, promises are eager. That means that they'll start kicking off right away. They are created. They start running code. They create overhead. They create memory overhead. So that's why if we want to basically really have them kind of you know, concurrency limited, we have to give it kind of, this is like a getter of a promise. So it's a function, right? And then if you invoke it, it returns a promise. So basically, we're not giving it the promise yet. We're just going to give it the way to create it. It's kind of like if people coming from like Java or so, that would be kind of, or C#, .NET, that'd be kind of like the factory pattern, right? Instead of giving it the thing, we give it the thing to make the thing, right? So in that case, then we only have the overhead of that function yet. We don't have yet the overhead of the promise, right? So that's why we have to do it that way. So now, and then we basically say run all of them, and we give it the concurrency. And then basically what it will do, it will just handle concurrency for us, and whenever it needs a new promise, it will run one of these factory functions, create a new one, and resolve them, and then basically it will return us back the results. So let's try that. So, and we probably want to await the results. So these will be users, and we're gonna await them, and then we need to print them still, right? So, by the way, just Puka. Okay, cool name. I did not think that this is the first time I meet someone by the name of Puka. So nice to meet you. Where are you from, Puka? Because I don't know where that name is common, which part of the world. So got sidetracked here with this naming. But basically what's going on here is we still got the results back, right? So there's nothing really cool about that. But we can now track with our little debug way to see how many promises actually were created and when. So let's look at that. So basically what's happening is we had concurrency 2, right? So 2 of them were executed right away. And then they resolved. And then 2 more executed. And then 2 more resolved. Now the thing is that they all resolve kind of together. And we can kind of see that, they get created really quickly. And then 100 megaseconds pass and no new ones get executed until, and they kind of both resolve very close to each other. And then the next ones get executed. So what we can do though is to show that actually so in this case it looks like, all of them have to resolve before the new ones get created, but that's not true. So what we can actually do, we can change the weight a little bit with the index. So which font? You're talking about the font in my terminal, I assume? So let me do that. Happy bitten bite. I hope that's better. Are you watching on a phone? That'd be interesting. I also find watching coding on a phone. Okay, yeah. Well, I hope that's better. And watching on a phone is kind of tricky, I believe. So I'm also going to increase this one for you. Okay, so what we'll do is we'll just make the weight different every time. So what we'll do, we use this the trick that map actually passes us the index as the second parameter. So we're going to use that, and we'll basically let's do times index to really get a different weight, and then we can actually see that the first one will execute, and then the next one will already the first one will resolve, and then the next one will already start executing even before the second one resolves. That's kind of the point. Oh, okay, cool. Where are you waiting for a bus and train? Where are you from, Bitten Bite? Trying to get an idea who's watching and where they're from. Here we can see that we're executing those immediately, right? 2 of them. And then the first one resolves, right? And then immediately the next one executes. Then the next one resolves, the next one executes. And we can see this like in order now, right? So it always makes sure that there are a maximum of 2 in flight, and it makes, it also tries to always have as many as the concurrency left. Oh, cool. Florida, nice. I basically just was there a few days ago in Miami, but just on the airport. I've never been in Florida, so should go. So welcome to the stream. What else? What was I doing? Okay, so now we're gonna do 5 just to show that this actually makes a difference, and then we'll be done with this one. So you can see here that right, we're getting 1, 2, 3, 4, 5 executed. Then we resolve one, we get another one, and so on. Yeah, no, I believe so. It's probably warmer right now. It's there's snow here in China, so I bet Florida has a little nicer weather at this point. So, any questions at this point? So the main point was to show that since promises are being used under the hood, we can use a bunch of promise libraries that already exist, which kind of make it, give us some functionality that we might need. One thing I want to point out before we move on, it doesn't work for all of them, and it's not, or at least it's not always as simple. So I tried, for instance, there was a promise cancel, something like that. So this one, I tried that one and I could not, it might have made a mistake or whatever, but I could not get that to work. It might be because under the hood it's actually not, it's actually creating a promise that inherits from another promise. So you can see here that this p cancelable is not technically inheriting from a promise. It has a then and a catch function or whatever. But it's actually creating the promise under the hood, and I'm not sure if that was the reason, but that one I could not get to work. So keep that in mind whenever we show, like I'm showing you the ones that actually did work, so I figured I should also show you that the ones that I couldn't get to work, so you know that that might also happen. That it's not just you. There are some cases where you can't integrate, but for a lot of them it actually works. So look at another one. We're going to look at memwise next. So let me first explain memwise. So memwise, basically, if we have a function, let me explain it with code though. I thought I was going to give a speech, but no. So this is a function and it memwizes stuff. Memwizer, and basically it gives a function, and then it has a cache. Could be a map actually, right? And so then what it does is if you basically it returns a new function, wrapper or whatever, and so if you invoke that with the args, it then will say if cache dot has these args, then return cache dot get the args, and otherwise what we'll do, it will say the result is execute the I think I have to do it. How in the world? I think I have to do it this way. Yeah. So like that, right? And then we'll say cache dot set args. And I hope I'm doing this right, but basically the idea is that we're caching back. Let's just simplify it and say you can only take one argument, right? So just to make sure I'm not making any mistakes with the way that args works here. So right, and then cache us, and we set the result, and then we return the result. So it's kind of like, so then I can say memwizer memwized. Let's say I have a function, and then basically I memorizer, and I give it this function, and now basically I have its memorized version of this function, and now I can execute this the same way that I would execute the function. So like this 12 whatever. That's basically what a memorizing function is. And there are also, you shouldn't write this yourself. I just basically did this to illustrate for you to understand kind of what it does. Basically what it does, it memorizes the results for specific arguments. So like if you have a really expensive thing, so let's say you have everything where we're actually going to, the network to figure that out. Let's say you try to get, I don't know, let's say you're trying to get let's say Twitter, and like, let's see what we have at Twitter. Let's say you're trying to get my avatar or something, right, from Twitter. So I give you a username and you fetch the avatar from Twitter. Well, the thing is that that may take a long time. So what you're trying to do is you can just cache those. Obviously, like, if you cache in memory, that might be problematic. Don't want to get too much into that. The caching, you can also cache in Redis, whatever, right? But I hope you get the idea. So now let's actually get into memorized promises. So basically, it's basically the same idea, except it works automatically for asynchronous code. The memorizer, yeah, I believe so. You don't want to calculate that every time. But anyways, if you're calculating Fibonacci sequences in Node, it may not be the best idea, because Node is not the best solution if you want to do something that's CPU intensive. Might want to do that actually in C. That's obviously the fastest one, most likely. You could even write an add-on that does it for you, and you know, on outside the main event loop. Don't want to get too sidetracked here, but yeah, Adrian, no, Alejandro, that's correct. If you cache that there, that will be pretty big performance improvement. So let's get back to the code over here. So what this is we have a function get user, okay? And so what that does is just basically is a way to return a promise. So we're returning a promise that we create, and the promise will eventually resolve. Boom, that's all. Now what we can do, we can say actually memorize this promise. So again, anything async returns a promise, right? So in this case, we are not memorizing a function, we are memorizing a promise. Okay. So what I can do is, basically when I say I get user memorized, I invoke it the exact same way that I would invoke get user. So you can see we're getting multiples of those, right? And each time, as you see, we'll use the same ID, right? So we pass ID 1, and we get it 3 times, right? And one time we use a memorize function, memorize promise. Yeah, basically, it is a promise at that point. And the other time we use a normal promise. And we can see that here we incur the overhead of basically resolving this every time. And here we shouldn't, right? So let's run it. Let's look at the results first. So okay, that's with the unmemorized version. So with the memorized version, should work the same way. No difference there, right? But now let's look at the performance aspect of it. So it's safe. So now we can see here that we're actually executing and resolving this promise 3 times for the same ID, right? The result is always the same, but we're doing it 3 times. Now, so that's not ideal. Now let's see what happens here if we do it with this one. Now you can see we're only executing and resolving at once. So it means like the promise is only created once and resolved once. So we have that overhead only one time because under the hood, things are memorized. So let's look at that. I hope I have that here somewhere. Now I'm going to get all confused with my huge fonts. I can't see anything anymore, but that's fine. Wonder how many people are actually watching on the phone. All right, so memorize. So you can even give a max age. Crazy. Pretty cool, actually. What I wanted to show is how easy this was implemented. So it's doing a mem, whatever that is. I think that's basically the cache, right? What it does is, actually that's not the cache. I don't want to get too much into detail, but basically it's depending on some other modules that we have to understand all this code. But it looks like it's basically creating it. Right. So what I want to understand is why doesn't it create? So basically because here's again, right? So that's the thing I wanted to point out. Why it doesn't create these promises right away? Why doesn't it execute the promises? Well, because this one is kind of like a promise getter, right? And we are basically giving is this promise getter. Does it make sense? So it doesn't. So once invoked with an ID, then it will actually return us a promise. So that's how it didn't create the promise even, which is important because just creating the promise already causes overhead. Because promises are ear. So here what we can see is we're passing as this fn, which is basically the promise getter, right, or the factory. And then here that's passed to the mem function. I think that's probably handling all this memorizing and caching stuff. And then it gives us a new function that we can execute, which then applies the arguments that we executed with. It handles errors. Oh, because obviously, right, if you have an error, we need to clear that because we can't keep, or we don't want to keep that value there. So, and then it throws that error. So that's kind of what it does. I don't know what that does internally, but the main idea is that we get another function back that we can then invoke, which will only create a promise if the result hasn't been memorized for those arguments. Does that make sense? So I feel like I'm getting a little bit into the details here. I wanted to mainly just show that you can actually integrate with this. By the way, so let me know if you're going a little bit too deep here, or also let me know if this is actually interesting to you. So if you want me to keep going into the details. But as I said before, if you're interested, you should definitely read up on this yourself and learn about how this works. So here's another one that was kind of interesting. I'm not a huge fan of it, but I'm just showing it because it was interesting. So what you can actually do, you can abuse, I would say, promises in order to consume event emitters with async await. So what this does under the hood, it creates a promise that resolves when the event is emitted. So you can also cancel. So it seems like they want everything to be cancelable. Interesting. A cancel is not it's not part of the promise spec. It's not part of the native promises that are built into JavaScript. There is a proposal for cancelable promises, but I don't know how far along that is. But basically, Sindri decided to make some of his promise libraries to make the promise that it returns make them cancelable. So what's happening here? We're creating some event emitter, and so basically then we create a promise out of that event emitter, and that promise will basically resolve when the finish event emits, right? So if this emitter emits an error, then basically it will do this. It will do catch. It's kind of a weird way. See if people seem to like it. So it's kind of like in here I actually called it a observe once because it's kind of like an observable, but since promises only resolve once or reject once, then basically it's not really an observable because it only happens once. So what's happening here? So basically, in this case, it makes a lot of sense because the server will only listen once, right? So what you have, we created an HTTP server here. Then we basically set up the request handler, right? What happens when a request? We just send hello world back, and then we say listen, and then we basically we want to actually print out that the server is listening, but only once it's actually listening. You could, most people actually, and that doesn't do any harm really. You can print out immediately server listening on whatever. But actually what you can do is you can actually go here and we'll actually do it in a second. You can actually do it server.address. I think it's like that. I can never remember if you spell address with 2. It's the problem is that in German you spell with 1, I think, and then. So I think you can do this. We'll see it in a second if that runs. So yeah, that worked, right? So it says on 555. So that's why you would want to make sure that you actually do that once server is listening, right? So what's happening here? We are giving it a server, and as you can see, the server has on method, so it's an event emitter, and then we say once it's listening, continue. So we're waiting here, right, until the server emits listen. Kind of a weird thing. It's a weird, interesting way of doing this. So event emitters are synchronous, but this is kind of happening at a later time, so we kind of can use a promise to handle that. It's kind of interesting. I wouldn't necessarily recommend to use it unless you have a real good reason, but basically this makes it code a little nicer, right? The other way obviously would be just to write a server.on listening, right? And then do it like this way, right? Put a thing here. So that's obviously the more normal way, but I just wanted to show this as an option. So we can also obviously print the whole address. Let's just do that just for fun. So you can see address, port, blah blah. So that's pretty cool. Any questions about that? I mean, it's just like a fun little idea. So I just wanted to show it for that. Another one that's actually a real interesting one, and probably a real useful one. So let's just say we're trying to fetch. So just to be clear, we're using fetch because fetch is returning a promise, right? And fetch also works in the browser, and there's this thing called node fetch that is the implementation of fetch, but in Node, but kind of like directly using Node features. So you could use it. You could also just use request. Request also supports promises, as far as I know. I think so. But we're using fetch, and then we're using this retry module. So, and then we can basically pass the retries via a command line argument. And so what's happening here now is we are telling it here on this line, we're telling it fetch hello world, and we're telling it how many times to retry. When we get the result, we'll just print it out. That's just pretty much, these two lines just print it out. Otherwise, if kind of fetch fails, and which means that it failed including all the retries, then we console log an error. Now, how does this now work? So here we have the fetch hello world, and we give it basically, we try fetch again, returns a promise. So this is kind of interesting, right? Because you're wondering, why does it return promise? I don't have an async in front of it. Well, I don't need that because I'm not awaiting anything in here, and fetch itself will return the promise. So we just basically have a function that, again, same thing, it's a promise getter, right? We have to give it a promise getter because we can't create all these fetches. We have to be able to create more. So if something fails, right, then it will retry. It will just create that same promise again. Again, the promise can only reject or resolve one time, right? So if the first one rejected because, you know, it failed, and we want to retry, we have to create a new one. We can't just reuse the old one or something. That's why you have to give it a promise kind of getter. So we give it the promise getter, and then we tell it how many times to retry. That's pretty much is. And let me open this in the browser. So this is pretty much it. It's also explained here. Obviously here they consume it in the promise chain style, but we kind of want to show how you can use it with the wait. That's pretty much all that there is to explain about this one. So now we're going to go to a separate terminal so we can have two terminals open. So what we're actually going to do, remember how we had the server just a second ago? We're going to use that server. So what we're going to do, so here, as you can see, it goes to 5555. That's exactly the port that the server will run on by default. So if we just run that server, which was number 20, right? So, and then we run our promise thing with the retry, and we say retries, let's say equals 1, it will resolve. Now, if we kill the server, just 1, it will fail, and it says retries attempt at 1. And basically, we attach that here, right? When we get an error, we just attach that information to the error just so we have it. Cool. So now let's say, what we're actually going to do now is we're going to say how long is it actually really retrying, right? So we're going to time it. And if you're wondering why I'm using this backslash time, that's just a better time command on the Mac. So that's what I'm using. So it took like 1.15 seconds. So if we take, like, let's say 2 retries, it should take about double, right? So let's see. Okay, so now it took 3 seconds. So it actually really did try twice. And if we actually fast enough and launch our server fast enough after like about 2 seconds, then basically the second retry succeeded, right? So now we got our hello world. Now if we do the same thing, so what we'll do to make this clear, we want to sleep for 1.5, and then we start our process, right? So basically, if we start that and then start that immediately with 2 retries, actually we need a little longer. Let's say we started after like 3 seconds. Now if we do here, do 2 retries, well, let's do it like this. We do 2 retries, so the server's listening now. Okay, so cool. So we have to do faster. Okay, so now server's not listening yet, right? First retry should fail, server's listening, second passes. Now if we do the same thing, and we do 1 retry, let me prepare this. So now it fails, and then the server's listening. I hope that makes sense, right? So it's actually working. That's the only thing I wanted to really show that it's working, and it works with async await, the same way that basically Syndra did want it to work. All right, and that basically brings us to the end of this episode. At this point, are there any questions? Let me know if there are any questions. You can see your chat over here, really nice, really big. So let me know if there, and don't go away yet. I'm going to actually announce something I'm going to do on Wednesday, which is actually pretty cool. So I see I lost pretty much everyone at this point, but I wanted to announce something. Well, I'm announcing it over Twitter as well. But if you have any questions, ask them now. I want to watch the chat. Okay, no questions. In that case, we'll go on to show you what I have in store for next time. So basically, let me actually pull my OBS thing over here. So this is my OBS. It's very small, I know. Make it a little bigger. So this is basically what I use to stream, right? So you can see, like, you know, the whole setup I have here, and then you can see my screen here, and this is where your chat is. And chat is slow today. Okay, actually I have a question. Okay, so let's do that first, and then we'll go back to this. So yeah, chat is actually slow. That's really weird. So Bittenbyte, can you please help with async await and web worker in browser? Whew. So let's think about this. So async await does not really create a new thread, right? Async await runs promises in a microtask. So as we saw, they're not really blocking, but the code that's actually executing one, you know, like the JavaScript is actually happening, all the JavaScript that's executing is still running on the main thread. It might execute a little later, it might wait till some request finished or whatever. Now, a web worker in the browser, what that is, it actually says, I want to run code, but I want to run it on a different thread. I want to not block, let's say, the UI. So let's say you're calculating, we had Fibonacci earlier. I want to still be able, for the user to still be able to press buttons. I don't want my page to freeze. That's what that is for. So basically, think of async await is for anything that is like an async task. And usually an async task is not running synchronous. So we're basically saying we're waiting for something, but it's not actually running JavaScript. It's not running in the event loop. It's like a request, for instance, a node that's happening kind of under the hood, and there's some stuff going on our network, whatever, and then we'll come back. But while we're waiting, it doesn't block the event loop, right? Now, the web worker, it says I want to actually run JavaScript, right? So I want to actually run JavaScript, and but I don't want it to block, right? So you're actually running synchronous code, but you want to kind of run it outside of the main thread. That's basically what a web worker is for. That's the main difference. So they don't really have anything too much to do with it. I know that there is someone wrote a web worker, the person who did React. So that was actually an interesting one. Let me show you that. So the person who did Preact, let me find that person, and then we'll find that library. So it was develop it, and that person did a cool workerize. I think that was it. So that just allows you to just put a function, say run that in a web worker. Now, what does it have to do with async? So here we're saying, so we're basically giving it this thing, and then we wait for the worker. Okay, so why are we waiting for the worker? Well, because it basically just gives us this nice little syntax. Because now the web worker is happening on a different thread, right? And so, yeah, thanks. I might found it before I saw your suggestion. So now, what it does is, so the web worker is kind of like, remember like how we had this thing with the event emitter? So web worker is basically also an event emitter, right? Because it says, I'm going to send messages back and forth. So you send me a message with the stuff you want me to work on, and I'm going to send you a message back when I have something done, right? So what we're doing here is we're basically awaiting for the worker to respond back with the result. That's pretty much how it is. So basically, this is just like syntactic sugar. So it's using promises under the hood to basically, so we can consume the result of the web worker like that. So we don't have to manually subscribe. And as you can see, so we have, for a call, it must be somewhere where we're creating a promise. Pretty sure it must be creating a promise somewhere. Or maybe it's happening inside the setup here. It's the loader. Nope. Let's look at this. Creating the worker. Setup, okay. There we go. There's our promise, right? Like I said, there must be some promise involved so we can actually await things. Somehow it must be returning. Can't understand the details at this point by just reading this quickly. But here we can say worker call is a new promise, blah, blah, right? So basically like and this is like what we're actually executing here, right? So worker call is a function that we awaited, and that does all this under the hood, and it waits for the worker to kind of respond back via an event, and then resolves the promise. And that's basically how he was able to give us this kind of really nice API. So as you can see here, it says worker.add, but worker.add should at some point. Well, there's some magic going on where it does then do worker.call. Don't understand the details at this point, but again, this is like something I would read if I really wanted to get under this. Just read the code, play with the code, debug through the code. You can debug through the code, right? You can understand how this works. So, so this is really cool. I like it. Okay, so yeah, so basically then you can build on top of that, right? But there was another question by Alejandro. Do you know Fastify? So that's a good question, Alejandro. I do not. I know Fastify. I do not know if it actually does use async await to make use a promise under the hood to make listen happen like that. Fastify listen. We might just look at. I would suggest read the code. It's beyond. I don't want to do it now. It's going to be way beyond. We're already kind of running towards the end. But go ahead and read it. And Alejandro. Join us other Wednesday next week or Friday and let us know. So even if I have a different topic, when I ask for questions or whatever, or usually at the beginning, very beginning, I just kind of open, tell me these kind of things. So like let me know. So this is your task to do. Find out. Maybe you can even paste some code into the chat and let us know, because that's interesting to know. But I would think that they're doing something like that. Right, Fastify.listen probably is using, it could also be that it's using a promise, and then it calls a server.listen, and then it resolves the promise or something like that, right? That's what I would think. Okay, cool, Alejandro. So, does async await? So yeah, the cool thing is, I hope I understand your question correctly, Bit and Byte. So async await, that's one other cool thing about it is that, for instance, you can see that really here that this one, right, is here, and the second one actually has access to user. So I could like put user 1 here, right, because it's in the same function scope. So that's kind of a cool thing. Like one await has has access to all the variables that the previous one had or created or whatever. With promises and callbacks and so on, that was a little more tricky, especially with promises. And then you would just resolve something with a promise, so you would get it into the next promise. It was kind of hacky. And so I'm not sharing the code. Thank you. So here we go. So right here, user 2, when we actually await user 2, we actually have access to user 1 here, right? And again, in promises, that wasn't quite as easily to do. And does it have window context? So now this is getting convoluted a little bit. So async await, yes, it has window context. If you're in the browser, it has window context. So any function, any promise, whatever that you're creating has window context. But if you're in a web worker, you don't, as far as I know. I know for a fact you cannot, access the DOM from a web worker. So in a web worker, you would do kind of like calculations, just pure JavaScript stuff. So you shouldn't need the window. I'm not entirely sure if you don't have any access to the window at all, but definitely you can't modify the DOM from a web worker, for instance. Okay, so now still have a few viewers, so I'm going to share what I'm going to do next Wednesday. So here we have my OBS, right? And you can see that there are, these things.